Hey, how's everybody going? John Tech here. Welcome back to the show. Long hiatus. Sorry we had to stay off for so long in terms of everything that was going on. Just truckload of busy stuff just kind of happening. Thank you so much for my like 70 or so subscribers who have stayed with the channel and perhaps learned something, perhaps been entertained by some things, maybe even shown their kids a thing or two. It's one of those things. But anyway, so I was outside today. Happy Easter, everyone. And if you don't celebrate Easter, well, happy Sunday. And if you don't celebrate Sunday, well, just happy whatever. Just, I hope you had a nice day, is what it is. I didn't. I had a great day until we started doing some lawn work, and that lawn work included me needing to get a leaf blower so I could blow the extra stuff off the way. And I went to go plug in an extension cord, and I had reason to believe that my extension cord, which I've actually got down here, that my extension cord, if you will, was perhaps defective, is what it was. It wasn't turning on or anything like that. So I went to go grab my multimeter, my BK Precision, Test Bench 390A multimeter. And my multimeter was indicating two things. Number one, that it needed a battery change, and number two, that this line was actually potentially defective. And so I went to go change the battery of my multimeter and realized that it's actually a little bit of a kind of a finicky thing with it on there. And actually, what I actually did was I grabbed a second multimeter, which is a Fluke 87V or 87.5, if you want to say the Roman numeral with it, which is actually, both these two are awesome multimeters, although the Fluke is really more of your like work model kind of multimeter, but whereas the BK Precision multimeter, I believe, plugs into a computer. Do I have a free USB port to even test that out? I don't think I do. I don't think I actually have a free USB port as of right now. I have like all my USB ports are currently taken up on my computer, but we'll figure something out with this. We'll figure something out to kind of test this thing out, because this thing has a USB connection that it can make to your computer for being able to load up the software on screen, which is actually really cool in a lot of ways to it on here. So anyway, so let's let's use a multimeter to test the battery of a multimeter and actually open the thing up. Which, I mean, like, getting a multimeter, if those of you who are perhaps new to electronics, this is kind of like your bread and butter tools. Like, the electricity is made of volts and amps and ohms and all sorts of other crazy stuff like that. This is the thing that like measures everything, and in a way, there's kind of one really good test that, I mean, you can really use for your houses. I mean, outside of just checking to make sure you have electricity before you touch anything or anything like that. Well, anyway, so what I'd like to do is actually use this multimeter, if you will, to get a couple of things going inside, test the batteries, everything like that, which you can. You can actually very much so test the batteries of the multimeter out. And I'm trying some new pieces of my software. Does the zoom thing work? Do I actually have a zoom? I actually have a zoom. That's kind of cool. You can actually see this thing on there. So, like, you see this? That's currently measuring. This is, hello, hi. Can you see that on there? Oh, good. Right? Can you see this even better now? No? Well, that's what it's set to actually as of right now. All right. And so there you go. That's just what it is right now. And so I've actually got a battery, if you will, a 9 volt battery, and I'm going to take the probe caps off of the multimeter probes right there and measure this battery. This is a 9 volt battery, and when set to the DC voltage indicator right there, it reads 9.01 volts, which is actually pretty good. This is what we call an open circuit voltage, and if it's a good battery, it's at or higher whatever the battery is actually rated at being. And this is again, not sponsored by, any kind of Duracell or an Energizer or whatever, bunnies, even though it's Easter, the not Easter battery right there, right? That is, in that blurry thing that's right there, it's at 9 volts, right? Or you could take, for instance, a AA battery, like this guy right here, and actually, and hold on to it with your hands and everything, and put the things across on either side of the battery. I'm kind of pinching it there, and you can see that these are supposed to be 1.5 volt batteries, and they're actually reading at 1.6, which these are actually brand new batteries. But if I, for instance, take my GameCube controller here and take out one of the batteries out of this thing, which I know is pretty used up. In fact, it wasn't even turning on earlier. You can see that this battery is actually currently reading at 0.9 volts instead of 1.5 volts, indicating that these batteries are more or less dead, and I can recycle them, put them out to the side, make a loud noise, that kind of thing. And so, yeah. So anyway, this multimeter is currently working, which is an important thing to be able to test batteries, everything like that. There is one very, very important test, though, that multimeters do, and that's called continuity. All right. So electricity travels through a metal, is what it does really, really well. And so you turn the knob so that you can get to this little horseshoe looking symbol, but there's actually one that looks like a big old beep. And when you press the beepy button and you touch the two things together, they makes a beepy noise saying electricity can flow through it easily, and it's connected, right? I take like a pair of metal tweezers that I typically use, and hey, when I touch the one side and touch the other side, it makes an obnoxious beepy noise. Right? So that's called continuity, which is actually a really, really important test for being able to perform on any electronic circuits, really, on any electronic circuits that, if you will, need to be tested out to make sure that there's electricity running through them. Most like, especially like wires going through houses, like speaker wires, that kind of stuff. Like it becomes kind of an important test. So I ran a continuity test on the cable that I've got here, the extension cord that I have, and I noticed something. I noticed that the ground wires are all connected up and everything like that. So that's a good thing. But when I went to go to the either one of the other two panels to this, I was not able to get any kind of connection on either one of them, indicating that this wire potentially has a break somewhere on the inside of it, and the wire is not very good. So this multimeter was used to be able to do that. But what I'd actually like to do is I'd actually like to open up the BK Precision multimeter and remove its battery from the inside. And to be fair, I did try this a little bit earlier. It isn't entirely trivial. Like, you look on the back of a Fluke, for instance, like these all run pretty much on 9-volt batteries, if you will. And so by taking let me angle the camera down a little bit more, you take the Fluke out by basically very forcefully peeling this whole part back. And then you have two locking screws on either side. Two screws that look, well, that's awful blurry. Hang on one second there. You have two locking screws kind of on either side, and just one big old honking screw right in the middle that once you unlock it, you could take this off to get to the electronics. But really, just to look at the battery itself, just to like take a look at the battery itself, there's really just these two kind of locking screws kind of on the bottom of it right there. Can I use my software to be able to do this? Is that a thing? Oh, good, it's a thing. All right. So those two little screws that are right there, you pretty much just take those two, unlock those two screws to get at the batteries that are on the inside of this thing. And actually, from the look of it, it still runs on 9 volts is what it does. So it might take a special type of 9-volt battery, because that doesn't really look like a 9-volt slot. So what I'd actually like to do, though, is to take my BK Precision multimeter, which I like to use because it can be connected up to a computer to be able to show what the voltages and everything like that is. And if I turn this thing on, it does make some noises as of right now, but I discovered something else that's kind of interesting on the inside of this meter. So what I'm going to do is I'm going to turn this off. I'm going to bring my camera out a little bit here, and I'm going to try and kind of show what this looks like in terms of removing the screws on either side, maybe a couple of close-ups to it, using microscopes for stuff and things, Okay, so let me get this to the point where it's like, okay, so here is where my finger is. Oh, hello. All right, let me move you so that you're in view. Can I move you so that you're in view. Ah, there we go. All right, so that screw is going to be undone first here. I'm going to back this up just a little bit so that you all can kind of see a little bit more about what I'm doing. What I'm going to use for being able to do this is a simple Phillips head screwdriver, which I actually thought I had one out, and I guess I didn't have one. Oh, yes, I did. I just put it off to the side. There we go. So we've got a little Phillips head screwdriver, and I'm going to slowly and carefully remove a screw. There are 4 screws on this thing. There are 6 screws visible. There's 4, 2, 3, 4 in the slot. These are the 4 that you want to remove to take the battery out. These other 2 that are back here, just remove kind of like the stand thing that are back here. And it's actually a little bit annoying to be able to get this thing back on. I don't even think I fully got it back on, to be honest with you. Now we're going to take the next screw out here. There we go. So there's 2 screws. Put the 2 screws kind of off to the visible side here. Okay, we're going to go to screw number 3. Where are you there? There you are. All right. So screw number 3 is coming out with it. I'm just using I don't even know if there's a number of Phillips head screw. In fact, normally like you say what kind of Phillips head screwdriver you're using with like a number with. In fact, I'm going to put this one down for a second and actually go into my iFixit. I have an iFixit torque driver, and I'm going to use with this. I'm going to use a PH1 screw tip with it. So I'm going to lock the screw tip into place. There we go. Go over to the last screw here. Put this guy in. I don't get as much torque off of this. Oh, that's not a good sound. I don't get as much torque off of this, but it is fitting into the slot just a little bit better with that. Plus it has the magnet for being able to pull this up. Now watch this silliness. All right, so watch this silliness. You have to kind of pop this thing open. And keep in mind, like one of the things that you're seeing on camera right now, this is the data port. All right, so this is the thing that the actual plug that plugs into the computer plugs into. The other end is just a standard USB cable, but this is an optical interface. So there is a light-based interface that this thing is actually transmitting data to the computer with on here, which I've always kind of found it to be kind of interesting that that's the way that they chose to do it. But when you open this up, you have to be very, very careful, because the actual light-based part of this, and I don't know if you can see that. I would actually like to point with a pair of tweezers that I actually had floating around somewhere. Yes or no? No, I don't see them there anymore, actually. Huh. I did have a pair of tweezers here. Hey, this is what everyone signs on to watch me lose things. That's really, oh, there they are underneath the case. All right, so I don't know if you can see this. I don't know if you can see this there, because it's kind of like sticking out of this thing. This guy, this thing that's right here, this thing that's right here, which is just standing on like 2 little legs, right? Like it's just those 2 little legs. This is providing all the data output going to the rest of the computer. Now, what happens when this thing gets bent? I'm assuming it's not going to work anymore, is actually what it's going to be. I really question this design quite a bit with it here. But just looking around the rest of the circuit, we've got some sort of what looks like a microcontroller. Several other surface mount devices are on the inside of it there. I see a calibration. This little guy that's right there, that little thing, that's a potentiometer screw. So that's probably used to calibrate something on the inside of this. And I actually see a number of them looking at this from the outside view of what this looks like here. Going down even further, we see another potentiometer screw that's used most likely for some sort of a calibration right here, all right, amongst a whole bunch of surface things. This large circular thing, this is the speaker, is what this is. This big old thing is the piezoelectric speaker that buzzes with this thing, all right? And next to it, we actually see some really large resistors to it. These resistors are easily, I think like not twice as big as a 1206 by far is what it is. All right, now you get to the battery. Now this is where I first opened the thing, and I actually found something kind of wrong that leads me to think that this battery might actually be okay. So this Toshiba battery with no mercury or cadmium on the inside of there is connected up to 2 terminals via this part of it right there. But however, when I first opened this thing up, one of the terminals, it was just barely connected to it. And as it turns out, this thing can kind of wiggle itself loose, is on here, and can just kind of feel free to slide around and disconnect it, not connect on the inside of it there, which is really kind of crummy. All right, really kind of crummy. So just with that alone, what I'm going to do is put the BK Precision multimeter off to the side. I'm going to bring back out the Fluke 87.5 multimeter, which is actually what I use to train with all of my students with in the college classes. They are expensive. That was the other thing. This guy is like $400, $500 for one of these things, whereas the BK Precision was only like $90 for it, in all honesty. So I'm going to test across this here, and I can see that it's kind of low. It's lower than the other one. They're probably not that much different, in all honesty. I did just grab another random 9-volt that I thought was in decent shape, but this one is somewhat low at 8.66 volts, and might even be dropping a little bit more past that. Some multimeters actually have their own set of battery testers on this thing, which is actually kind of interesting. I think my BK Precision might have that. I don't see it on there, which is too bad. So it has a lot of other stuff with it, but yeah, so the battery should be replaced on the inside. So what I'm going to do is bring the BK Precision back onto screen again. Hello. All right. And there's my 2 terminals. I'm going to slot and slide into place the other 9-volt battery, pressing fairly hard against these contacts. I'm going to try to actually push those really well into place there to see if that's in there. And there's still a sizable gap between this thing to it here. Again, I'm really perturbed by the optical interface. The whole thing that connects up to a computer is just literally sticking out of this thing like a sore thumb. And if you put the case down wrong on this thing, I don't know if there's any way it's going back. I'm hoping that this LED is like really wide angle. I don't even want to really touch it all that much, just because if I bend it or anything like that, I don't even know if it'll still work and connect and everything. You got another little bits of circuitry right there. Some of the circuitry around where the connectors are looks like it was a module, like a multi-module that's with it. And a 20 amp fuse. This thing takes 20 amps? Really? This takes 20 amps? I'm shocked. Yeah, it does. It says 20 amps. I'm not gonna lie, that's kind of cool. Oh, check that out. There's a little hidden compartment in this thing. Bring this guy up here. There's another fuse on the inside of there. Fuse protector cover, do not throw away. Well, all right then. Won't throw it away. I'll put it back on it right there. All right. So that's how the insides of this thing. So I've got a battery in here, and if I go ahead and just try and turn the thing on, I get a beep, and so it sounds like it's turning on and everything like that. So now what I'm going to do is I'm going to very carefully. Ugh. See, I feel like I'm catching on something doing this. Like, I feel on this side that I am actually touching some part. Can I see the sensor? Can I see what I need to see to make the thing do what I need to do so I don't break it? Is it in there? Oh, I think I see it in there. All right, so get in there. Nice little blue LED. I see you there. Hello there. How are you? You need to be cleaned a little bit there too, I can see. All right, so that's good. All right, so that's back to where that was. That is very, very awkward in comparison to other multimeters in terms of changing out some of their parts to it. I gotta say, that's a very, very unique for that one. All right, so now we're going to screw one screw back in. And screwing them back in with the PF1 bit. I think that's the PF1. Looking back in it again. Yeah, PF1. Phillips 1. Is that what that stands for? Leave a comment in the comment below. That's potentially what that stands for. If I'm wrong, I'm just, I'm no expert or anything like that. I am an instructor of sorts, but at the same exact time, if I'm getting something wrong, I'd rather have that pointed out to me and, you know, get it right the next time I'm going around doing stuff with it on there. All right, so now the next one is in, nice and tight. And we go to the next hole here. And the one thing I like about the iFixit bits is the magnetism is excellent in terms of being able to grab just about any type of screw that I'm really kind of working with here. So any kind of screw, really. There we go. Screw goes in. And then lastly, the last screw is going to go in on the opposite corner here. All right, so the last screw goes in. And there you go. So does the BK come back on? It sure does. Does it do the test though? That was where I was having a problem with this thing. It was like it wasn't doing the, oh my gosh, the bright stuff to it there. OOL for overload is what that is. Let's see if it does the audible continuity test, because that's what I was trying to test with the extension cord earlier, was that I was trying to get it to do a continuity test and it just wasn't doing it. There we go. I get a nice beep when I touch the two probes together. I get a nice beep. I get a numeric reading indicating that there's a low resistance value, meaning that there's a lot of metal that's getting connected through to make this thing actually do what it needs to do. But the wire itself is still bad. But yeah, what I wanted to do was show you the awkwardness, a little bit awkward style in terms of like how this thing actually gets its battery changed and everything like that. So a little bit educational, a little bit unique and everything like that. So yeah, what's your favorite multimeter that you use in your home that you'd recommend for someone? Is it a BK, is it a Fluke, or is it something else you may have gotten from a Radio Shack or something like that? Leave a comment down in the comment below, and we'll see you around on the next one, folks. All right, see you later. Bye-bye.